Let us try to understand how an inductor behaves in a circuit. So in simple language, like we've already discussed in the last few lectures, that a solenoid when used in a circuit is called an inductor. Okay, if you use a solenoid in a circuit, it is called an inductor. Okay, so now let's try to understand first of all the function of a solenoid. You know that if there is a solenoid and there is current flowing through a solenoid, then there will be a magnetic field in a solenoid which will be in this direction if the current is in this direction. Okay, so the current will be flowing in this direction and magnetic field will be towards the left. So this will be the magnetic field in a solenoid due to current I. Now we know that the magnetic field in a solenoid is given by mu naught small n I. And what is this n? This n is actually, if there are n number of turns in this solenoid, like 1, 2 and so on, if there are n number of turns, then, and the length of this solenoid is L, then small n is defined by capital N upon L into I. Okay. Now if the current is constant, then the magnetic field inside a solenoid will also be a constant, because N is constant, L is constant, mu naught is constant. So the only variable here could be I, but if I remains constant, magnetic field will be constant. But what will happen if this magnetic field will change or current will change? So let us say that the current, first of all, let's say that the current will change. It can increase or decrease. Let's say that it increases. Okay. For understanding, we're taking this example, but you can also take it for a decrease in current also. So if the current will increase, the magnetic field inside a solenoid will also increase. Now what does Faraday's law says? It says that EMF is equal to d phi b upon dt. And what is the meaning of this? It means that, and there's an n here for n number of turns, it means that change in flux magnetic flux and EMF induced, and this negative sign means opposite. So a change in flux will give rise to an EMF such that the EMF will oppose the change in flux. So EMF and change, they will oppose each other. So what is the meaning of this? It means that if the flux will increase, EMF will try to decrease the flux. If the flux will decrease, EMF will try to increase the flux. Okay. Now let's try to use this law here. We are saying that the current is increasing, magnetic field will increase, so the magnetic flux will increase. So it means that if the magnetic flux will increase, EMF will try to decrease it. So it means an EMF will be induced such that it will oppose the change in flux. That means change in flux means change in magnetic field, and change in magnetic field is due to the change in current. So it means this EMF will oppose the change in current. Now what does this mean? It means that if the current will increase, EMF will try to induce a current which will oppose this current, so it will have an opposite current. It will try to decrease the current. Okay. So in the solenoid, if there is a current I and due to this there is some magnetic field B, and if the current will increase, an EMF will be induced which will try to decrease the current. So it means it will try to oppose the current. And this opposition, it means it will behave like a battery which will have a positive this side and a negative this side. Okay. So this will have an EMF which will be given by minus d phi b upon dt, or minus L di upon dt. So it will behave like a battery which will act opposite to the current. Now it depends on the current. If suppose that we have the same inductor, current is flowing in the same direction but current was decreasing. If the current is decreasing, then you know that the magnetic field will still be in this direction. It means that this current is decreasing. Now EMF will try to increase this current. So if it tries to increase the current, it means that it will try that the current should move in the same direction. So it will behave like a battery which will be like this, positive this side and negative, so that the current will flow from positive to negative outside the battery. Let's take a few more examples. So if there is an inductor, okay, and in this inductor the current is flowing in this direction and the current is decreasing. So if the current is decreasing, it means that the magnetic field is also decreasing, magnetic flux is decreasing. So it wants to increase the current. So it will behave, it wants current to be in this direction. So it will behave like a battery which will be so that it can create a current in this direction. Another example, let's say that the current is moving in this direction and it is increasing. If it is increasing, EMF will be induced which will try to decrease the current. So now EMF will try to decrease this current. So it will act opposite to the current so that it can oppose it, it can try to decrease it. Here it is decreasing, so it wants to increase it. So it wants to enhance it. So initial current is in this direction, induced current will also be in the same direction. It is induced current and this is the current we are using already, so it will try to enhance it. While here it is increasing, so we want to decrease it, so it will oppose it. So it will behave like a battery which has positive this side and a negative this side. Okay, and if there is another inductor and the current is flowing in this direction and the current is decreasing, so it means that it would like to increase the current. So if it wants to increase the current, so it will enhance it, it will try to increase it in the same direction. Okay, so this will behave as if positive is in this direction and negative is in this direction, and it will have an EMF of or delta V of epsilon which will be given by minus L di upon dt. Okay, now if suppose you have an inductor and the current is constant, then it will not behave like an EMF. Then EMF will be zero. It will behave like there is nothing, there is no potential drop, because there will be no potential drop. EMF means the potential drop. Okay, so it means there is no potential drop. So if there is no potential drop, it will behave as if it is a wire which has no resistance, and the current can flow very easily without any hindrance or obstruction from anywhere.